exponent. So let me recap. I think you know how to do it. It's like an exponent. You can have multiple things inside raised to another one. You multiplied. You know, like I think the ones you were doing with me last time, I think you were adding. So you multiply, like I'll do a dot here. So this is the property. However, this one is already fancy, has a 3 as part of it. Oh, like the y, let's say y raised to the 4th like this. There's a 1 here. Ignore the 3 for a second. That's why it's going to be y 1 times 4. But you can just throw it in there, I guess, y to the 4th, you know. But the 3 itself, kind of like I'm gapping this so you can see like what I'm seeing. You could throw in the 4 into the 3. It's like there's a 1 there, like 3 to the 1st. So it's 3 to the 1st times, 3 to the 1st power, the 1 times the 4. So if it's like 3, 1 times 4, or it's going to be 3 to the 4th. Together, it's really 3. Here's like the work. This is what you should be doing next. So to do, and then simplify. Therefore, 3 times 3 times 3, 4 times, what is that? 81 y to the 4th. Final answer. So it's really this that I see in my head, that like the next step. It's like you give the 4 to the 3, like multiply to the exponent, it's already there, a 1. And then the y to the 1st power, you don't see it, there's a 1. You multiply that 4 to the 1. And that's why I get this. This is what I see, the next step you should be writing when you do it in real time in class or on your homework assignment. You should be writing this very next step. After that, the problem. And then you simplify this part. So it's like 3, 3, 3. 2, 3 is 9. Another 2, 3 is 9. So it's 9 times 9 is 81. So there's your answer. Let's put it in. I hope you're okay with that. Yeah, you get more. You get more of these, and you'll be like snap. But yeah, okay. Let's enter 81 y to the 4th. Now, some people are still seeing it like 4 times. That's too much work. You know, imagine 3y, 3y, 3y 4 times and multiply them. That's too much work. You realize that if you raise to like the 60th power, what are you going to do, right? You're not going to write that like 60 times. Imagine that. So, okay, this one, I mean, same idea is, but since this one is only raised to the 2nd power, you can see 2v times 2v, 7v times 7v. So it's 49v squared. But be careful, if it's raised to the 12th power, you don't want to write that like 12 times, right? So you'll be writing, hey, 7 squared, v squared. That's what I would do again for practice. So this is like the next step that you'll be writing, and then it will turn into that. Inside the parenthesis, 7 is raised to the 1st power, 1 times 2. V raised to the 1st power, that 1 is timing 2. So this is what you should be writing in class or on paper. And then you simplify this into that. So it's 49v squared. Is that okay? Or, since this is just like 2nd power, you could be writing this and then, or see it in your head if you want. You can write it even, because it's just like short. And then you simplify it to become 49v squared. Is that okay? I hope you're okay with that. Let's put that in. 49v squared. I'm betting anything will get really fancy right away. Yeah, as I expected it. Now, here's the deal. It's not a bad idea for you to imagine this time 4 of them. I wouldn't write it though. Waste your time. 4, imagine bloated up variables, like set of 4 parentheses. Imagine that you're multiplying it 4 times. However, the reason why you may want to imagine that is because if you have a negative inside the parenthesis raised to an even power, and it doesn't matter how big, how long, you have a negative inside the parenthesis, it doesn't matter how long, raised to an even power, it will be positive. You can try to imagine it. If it's raised to an odd power, it will be a negative answer. If it's negative inside. I'll show you more, but right now, if you want to see the actual work, it should look just like this. Here's the next step. It will look just like this. Dot 4, B 1.4. Now, some people don't put the 1. You just put the 4. like b to the fourth power. But this is critical for you to write if you're going to do, because it's raising the fourth power. I don't think you still want to write four of them, like four of those side by side. So this is the second step based off the property that you're supposed to be learning. Parenthesis, no kidding. Group that negative with the 3 must raised to the fourth power. It doesn't matter what the power is. You're going to group that negative 3 and raise to whatever the power is. This could be the seventh power, whatever. But the answer will be, of course, different, negative or positive. It depends on the. So this is even power. So the answer is going to be 81, positive 81. You can think negative 3 times negative 3 like 4 times if you want. But it's easiest if again, if you want to make it short, if you have something between the parentheses raised in even power, it will be positive. Therefore, you ignore the negative and then just go ahead and do the 3 to the fourth power, which is 81. 3, 3, 3, 3, 4 times, 81. And then the A, 2 times 4 is 8. B, 1 times 4 is 4. So here's your final answer. You don't have to write this part. This part, you just multiply it if you want. Is it okay? Like, just write A to the 8th power, B to the 4th power, just like that. You times it. But this here, you may want to at least write it. I recommend you write it so you get used to not making the mistakes of the sign and the parenthesis thing. Remember I showed you like in the calculator that it's not the same when it's raised to the odd power? This is the situation right here. But you're raising it to an even power. But it's raised to the odd power. You still need to parenthesize it. And then it'll be negative. But all right, this is the answer. I hope you're okay with that. Again, you can write them 4 times, but you waste a lot of space and a lot of mental energy if you write this 4 times. I'm talking about like this. I don't recommend you do it because you're not going to be able to do it for the 8th power. You don't have space to write on the paper, or the 14th power. They would do that. You might think they're like messing with you or being crude, being mean. They'll raise to the 100th power very soon just to see if you understand the concept, like the exponential properties of multiplying and all that, So they'll do it. They'll raise to 100 power. I don't know what's going to happen here, but it will. Especially with imaginary number, with the I concept. We're not doing that just yet, but it's based off this concept. Okay, now this one, it's a bit fancy. You just have to be patient when you do your math. Like, you're not going to mentally do this, okay? You could. You'll spend about 5 minutes to mentally do it without writing anything. 5 minutes, I don't think so, but maybe 2. But it's not practical. You don't want to do that. You make mistakes if you do it, okay? So don't even bother, yeah. But I'm saying, let's say it's a quiz or a test. Okay, here. What you should be doing is this. There are a couple of ways of doing it, but the most common way is this. Let me show it to you right now. Since the first set of parentheses has nothing raised to another power, I'm talking about, wait, let me write it first. I'm talking about out here, there's nothing. It's a 1 power, so leave it alone. So it's like, just copy and wait for it. Wait for it to be combined. But this next one, you want to write it like the way I showed you right now. The 2 is raised to the 3rd power, like this, with the negative. Now you might be thinking, why shouldn't I put it in there? Yes, you can, but remember to be safe. What if it's raised to an even power? So do this as a practice. This is how it's supposed to be taught. I'm just saying right now. And then the second one, okay, I think you may be able to do this like this. You don't have to write 2.3. Just go ahead and do 6. Tell me you're okay with that. Then y to the 9th power, and then z to the 9th power. Just multiply it. Is that okay? So I'm skipping like the show of work, like the 2.3, 3.3, 3.3. So let's just, because everyone would do it like this, okay? So as you can see, I don't have the parenthesis anymore because I executed what, I raised the 3rd power for the back end, the second part. I don't have the original written, but you know what I mean. And then continue with this. Here we go. What do you do? Okay, check this out. That's why you want to be patient. This negative has nothing to do with combining with the other one over here, not over there. This negative belongs to the x squared, or it's independent. You can think it's -1 times that whole thing. So watch. I know it's like, dude, this is too much. I don't like it. Yeah, it's like you either can see it stuck with the x squared, or you pull it out as a -1. Because why? Okay, forgot to mention, why can you do that? Because again, this is not raised to any power for you to evaluate the sign being positive or negative. It's negative. You don't raise to any power. That means it's negative for at least for this one right here. It's negative. So that's why, to emphasize it, go ahead and put a -1 to emphasize that stays negative. That, yeah, if you wonder how to emphasize a thing being negative, put a -1 in front of it, and everything else as is, and then simplify this. That's -8. -2 times -2, -8. So here, I'm writing at -8, and I copy everything else. Now, you don't have to copy it. You could have done actually simultaneous work. You could have actually combined this, like this with this with this, and this with this right off the bat. But I wanted to write it out so you know what I think your thought process should be. Hey, don't mess with the back yet. You can do simultaneous work, yes, but I worry that you might think that, hey, this is actually going to have to be combined with the other stuff back here simultaneously. No, you can treat it. So that's what you can do them like slow ass way, slow ass way. I'm making emphasis on that so you can get the answer correct. So you see it? And then now one last step. This negative and this negative now become positive. So this one, I think everyone will mess up if you don't be patient here. So it's going to be 8. So I'm taking this out now. Or organize it in the front. Then this one and this one. Remember, you now have two bases. You add the exponents. It's not that power rule. It's not the exponent. The raised to a power rule. So you have to add the exponent. It become 8 times. X to the 8th power. See that? And the y. This is y to the first, y to the 9th. That's y to the 10th power. And then the z, your last term, it'll be c to the 11th power. Final answer. So I'll tell you, this can be done a little faster, but I recommend you do it like, chill out, just bit by bit. If you don't, you're likely to, at least the sign error mistake can easily happen. But I hope you follow this, right, Alex? Yeah. Again, this can be done differently, a little faster, and organize it differently also. Yeah. Okay. This one. Again, you can write this 4 times, but now you realize you don't want to do that. Look how chunky that stuff is, the fraction, right? You don't want to repeat that. So here we go. The numerator, you treat it separately from the denominator. Give the 4 to the numerator, give the 4 to the denominator. Same way. So here we go. It'll be 2 to the 1 times 4. So it's 4, like the exponent 1. And then x to the 20th power, you multiply. So this is how many of your classmates will do it, okay? Knowing that it's 5 times 4. Anyway, 3 to the first power, the 1 times the 4, it would be 3 to the 4th. Be patient. You can do the math here without writing the 2 to the 4th, 3 to the 4th. You can do the math. It becomes 16 and you're 81. You can write that. But I'll write it like that to be safe. I recommend you do it. Again, you don't have to. You can just simplify that without writing the exponent to the 4th power. Anyway, x 7 times 4, 28. Y 12, 3 times 4. And then continue. Treat this as like a brand new problem. So if you continue, this will be 2 to the 4th power is 16. 2 to the 2 4 times, or 4 and 4. Again, 3, 4 times, spread it out. A pair of 3 is a 9. Another pair of 3 is a 9. 9 times 9 is 81. And now this one. Okay, let me test you out, dude. How fast can you do this? Let me see. How do you combine them? Obviously, the y to the 12th power will be where it is, right? You don't have anything to combine with, so I stay where it is. But now, how do you write this in here? Let me see. You can do it in one shot and get the answer, or you could write one and then continue with this one more step. Yeah, I want to see if you cut on to do it a little faster. But I want to see. If you don't get it, I'll I'll make you example a new example, and I'll bet you get it like the fast way. But tell me, what do you think? How would I feel it?
Would you like minus them?
Yes, sure. You will. Okay, what will it turn into? X to what power?
It would be like to like the eighth power or like the negative eighth power.
Negative 8 power. If you are gonna, you have to think that, because the top dictates, the top go first, the bottom you subtract, go after. Okay, so it's negative
Yeah.
8. But if you were to write negative 8, you have to write it in the numerator. Always. If you ever, it doesn't matter if you
Yeah.
subtract it to be positive or negative, right? Whatever you do, you still subtract. You have to write it in the numerator. But if you ever come up, if you subtract and you ever come up with a negative, can you actually skip a step? Tell me where to write it. It is x to the negative 8 in the numerator. But I want to write the final answer without having to write that in the numerator. Where would I place it?
Uh, so not in the numerator.
Yeah. Yeah, if you write it in the numerator, it will look like this, right? Watch, negative 8. But that's not the final answer. Yeah,
Then where
that's,
do you put it? Would you put it without the negative in the denominator?
yes, that's how you do it. So that's how you do it. Is that okay? Now, another way of looking at it, I guess I don't have to show you an example. If you look at this carefully, right, there are two 20s on top. I'm sorry, there, there, there are 20 x's on top, and then 28 x's on the bottom. You're going to cancel 20 on top, and you're left with 8x on the bottom. That's why this is the answer on the bottom. Now you can. Now that may be a little strainy mentally. You can think of it like the way we just said it, the way you said it a moment ago. So you subtract, it's a negative 8. But a negative 8, every time you get a negative, you better write it in the numerator. But that's not the final answer. So bring it down and use the conversion. Remember the negative exponent, make it on the bottom, that conversion, that rule. So therefore, it'll be brought down on the bottom. Now, this may be a little strange because you're putting it, next to everything else. I think you've done it like by itself. You know what I mean? Like something, the x by itself. Yeah, same idea. Just bring it down. It's really like multiplying on the back if you want, right here, 8, and then you bring it in commutatively, like switch it commutatively, a commutative property of multiplication in the denominator. So that's why you can do that. So yeah, this is the fastest way. So try to imagine negative down positive. That's done. Or that long ass, sorry, I keep saying the word ass, the long 20 x's, 28 x's on the bottom, you cancel them out. But that's, to me, it's mental strain. But it's still good to understand why or where it's located, right? The leftover, the 8, x to the 8th power, 8 of them. All right, this is the answer. Oh yeah, sorry. Can there be a number can divide into 16 or 81? I don't think so, right? Not 3, not 9, no. Yeah. No, so yeah, we're done. 16, just 16 on top and all of that on the bottom. Yeah. Yeah, yeah. Yeah, continue on. Yeah, continue with the bottom portion. All right. I hope you're okay with that. Again, this can be done differently also. Okay, this one. But anyway, the way I showed you is actually the very nice way. Okay, look, the next step. And only the parenthesis portion is 1. So therefore it's 2 times 1, 0. Now there's negative in front. Remember, I was telling you, there's a negative. If there's a negative, put a 1, emphasize it. And then this is another 1 on its own. So the answer is negative 1. Oh, sorry. It's a, sorry. Oh, I forgot. And this one's negative. There's negative 1 front times another 1 on the back. There you go. Okay. Now, here I showed you. I was thinking, have you teacher showed you that? Like the negative on the bottom, you bring it up on top as a positive number? You know what I mean? It's like the other way around, like, it's vice versa. And there's proof. I mean, I can show you if you're curious. Why? How did it come up with stuff like that? But let me first quickly. Here's how 4 stay where it is. The coefficient 4. But let me write it. So I only add this portion and it'll bring it up. So therefore, everything else will stay as is. So 4 stay 4. The 1 you can write, but you don't need to write it because if it's probably gonna tell you don't need the answer. It says right, correct. But it's probably gonna tell you need the 1. Now you becomes it 4. So here's your final answer. I hope you're okay. Yeah, that 4 is separate from the x to the 4th power. It's time is separate. Yeah. Okay, good. And why you can do up and down like that. We have time to show it to you. Makes sense. Okay, now here we go. There's this one. Really, you do have different ways to do it. Now, let me explain. So if you do the I would say longer way, you're probably gonna bring negative up, all the negative up, be positive, bring on the negative up on top, bring it down positive, like that. You can do that. That's one way of doing it. I think many students do that. I don't know. I'm guessing maybe half and half. The other half will do it this way. So I don't know. Okay, wait. I do know. Let me think. Okay, let me explain. This one is so close. Either way is not the same, but have a look at what I think you can do also. 2 can to 10 5 times, so I'm writing it on top. Now remember, if 10 2 is 5, where do you write it? If it's a fraction, write it in the numerator. That's 501. 501, therefore it's in the numerator. Okay? Now this part S, check this out. You're going to subtract. It's 7 minus negative 4. So that may be the faster way because when you do that, it will be in there. 7 minus negative 4. So it's 7 plus 4. So it's x to the power. Okay, right, here we go. To the third, divided by y to the negative 1. So it's y minus negative 1. So it's y plus 1. So it's going to be y. It's 3 minus negative 3 plus 1. So it's 4th power. Now, what about the last? There's nothing. The last one, just bring it down. There's nothing to combine with the z. So this is done. It's then bring up, and I'll show you in a second too. But this is the answer. But you can imagine x up, positive, bring the y up. It's like you get to, then you have to do an operation to multiply them, right? You got more work to do. This is technically a faster way, the way I took through by subtracting. So there. Okay with that. But be careful. Subtract negative, subtract become positive. Okay, this again, there's more than way to do it, but I did kind of at least describe another way. Now, there's 2 ways of doing this one right now. So let's see one is faster. I'll hop off here. Okay, the first way is this. You multiply them just like the way you know you can, like b to the negative 10, but then you bring it down as 1 over b to the positive 10. Okay? This one, watch, you can do it this way. You bring it down right now. It becomes b. This is pretty advanced, okay? I don't know why I use the word advanced. This is what you can also write. You bring the whole thing in between the parentheses down and make the exponent positive. Get it? You see it right there? And then you can then b to the 10 power again. It looks a little fancy because I don't think you've ever seen it done before. It's like something inside, chunky thing inside. It's not even chunky. It's like only v to the 5th power. But you bring the whole thing down. Let me make it here. Anyway, let me do some fancy here. Raise to negative 2. Take a look at this problem. Z. This is z. Guess what? You bring the whole thing down. This is it. This is the answer. So that means you can however big it is between the parentheses, you bring the thing down. I'm sure you still keep the exponent positive. Okay? That's it. Now this way you can do more, but I just want to show you that you can bring the whole thing down. Next one. Same thing. You can bring it down and make it positive on the bottom, but it will be 3 positive, okay? Or you can multiply them in. Now, I'm going to multiply them in. Or, dang it, you see? Now, if you do multiply them in, it will look like this. That 3 that in the front of the parenthesis would be 3 to the negative 3. Okay? Like there's a 1, 3 to the first power. 3 is the 3, the 3 is the first power. So 1 times negative 3 is negative 3. Then A to negative 15, I'm multiplying it. Then B, a positive 12. So this is like the next step. And then have a look, okay? Here's the final step. B12 in the numerator, because don't forget the original, this step is really over 1. I hope you're okay with that. Everything is over 1. Therefore, that B to the 12th power better stay in the numerator, because there's stuff that you can bring down in the denominator. So it'll be 3 to the 3rd power, A to the 15th, positive 15th power. And then you simplify the denominator, because you can do it right there. So B12, B to the 12th power, and then 27, 3 times 3 times 3, and A to the 15th power. There it is. Final answer. But I'd like you to see this. The next step of another method looks like this. Here we go. So you have different ways to do it. You can choose which way you think it's best for you. But I want you to see both ways. It's what I was showing you earlier, but now the whole chunk is brought down. See it right there? And then multiply that in. So if you do multiply that in, you get 3 to the 3rd power, which is going to be 27. A to the 15th power, B to the negative 12. But you're not done. You got to bring this back up, and it will be this answer again. You see it? So you can tell that it's the same thing. So here, let me write the final. B12. So you choose which way, but I recommend you know both ways. Recommend you study both ways, because it will come in handy one time, or one way, maybe another situation another way. You'll know it when that happens. I think you'll know it because even I'm like, when is it going to happen? Yeah, but either way, it will happen. The situation where which one of these will be best. I'll say it this way. If there are a lot of negatives in the original between the parentheses, and you raise into another negative, it's more negative than positive, then I would do it this way to counter it, make it a positive. You get it? Like you multiply it in to make them all positive. But this one has half being negative, half being positive, so it's not going to make much difference. So I hope you understand what I'm saying there. If the original problem has a bunch of negative in between the parentheses, fraction or not, and it's raised to a negative again, multiply them in. Because you can get rid of the sign, make them positive faster. So I hope you understand what I'm saying there. So that's why I attempted it, like right here. I multiply the negative in to make it a bunch of positive, if I can. But this one has half and half, positive 5, negative 4 inside the parenthesis. So anyway, same answer. I hope you know both of them. Yeah, so look at them, okay? Either way, it works. Oh, raise 12. Oh, fix the numerator. you you times it by 12. Yeah. Yeah. All right. Okay. Oh, here we go. It's getting there. There's 2 ways of doing this also. Wait, did you get this okay? Are you getting this okay? Yeah? Okay, yeah, both ways, okay? Now, this one has 2 ways too, when it's fraction. I know I mentioned you multiply it in. Yeah, you can multiply it in right now. Okay. There's 2 ways of doing this, but the second way, you must know this rule. Have a look, okay? A could be chunky, B could be really chunky in the numerator, raised to a negative n, negative whatever power, but negative. You flip-flop it and make it a positive. So this is a fraction rule. Your teacher may not have shown you this, but it is true and can be proven. And this is also documented. It's, unless your teacher may not have shown it to you or taught you, but it is documented. It is part of algebra. It's part of exponential properties. So I'd like you to see all of it if your teacher hasn't shown you it. So what does that do? Well, I can flip-flop this one. I'll apply this one right away, and I'll do it like the other way too. I'll do like the normal way that you know. Let me do the normal way first. The normal way, I'll multiply it in. So it'll be 3 to the 1 times negative 3 would be negative 3. And then B, negative 9. And then C, positive 15. I hope you're okay with that. And then clean this up. You'll bring all the negatives down on the bottom and make them positive. So I'll bring them down. So I'll keep this, I'll put them in order. I'll put the B in the front of the C. It'll become B to the positive 9, C to the 15. I'll push it to the back. And then this is going to come down also. It'll be 3 to the third power. Right there. Okay?
Yeah.
But that 3 to the third power is 27. I'll keep it there. Third power, positive. Now, you brought everything down. What's up with the numerator? What do I do in the numerator?
Do you put like a 1?
Yes. So I wanted to write that on purpose for you to see. And then you clean it up and the answer is done. It'll be 27 here, B to the 9th, and C to the 15th. Now, let me do it this way. Have a look, okay? I'm going to do it this way. This is a property your teacher may not have shown you. It's not advanced. It's actually could be introduced whenever. So next step, I'm going to flip-flop it and make it a positive. Here we go. I'll flip-flop the fraction and make it a positive based on this rule here on the side. Positive 3. See, now careful. Everything will stay inside. Everything, the signs stay the same, okay? Just don't fix that into positive for no reason. It's just, see the A and the B, just flip. Nothing else. Nothing changes. It'll be 3b to the third power. So I apply this rule right here. But we're not done still. And then multiply it in. Multiply in. Multiply in. So I multiply it in. It'll be, oh no, I don't need the parentheses anymore. It'll be c to negative 15, 3 to the third power, b to the 9th power. And then almost done. And then I'll bring that down on the bottom. C to the positive 15. Then b to the 9th as is. And then 3 to the third is 27. And then again, you don't have anything left in the numerator, you put a 1. Same answer. It looks about the same at work. Now, this rule it's handy for certain situations again, okay? I'll say. But anyway, final answer. Hope you follow okay, right? Yeah. Sometimes when you don't write it out, you may have to think harder when you do it on paper. So, but at least you see it. I think you'll be fine. Yeah, you see the work, that I've shown you. All right. Right, next one. Okay, same idea again. I'll just multiply it in. Oh, wait, it's already positive, so you don't want to flip-flop it. But you could, if you flip-flop it, the negative is going to be raised to a negative 3. It's like the other, it's like inverted. Get it? It's just like that. You bring it up, positive, same thing. Yeah, if you wonder, you can force it. Now what I said just a moment ago, have a look, okay? It is so important in calculus. Watch, this here is positive. If I flip it, because I need to flip it, be a negative. This making it to a negative is important in later math. It's so important to get the answer right. But it's not common, but it's important to be able to do it. You know how to do it. Yeah, to get the negative exponent out of it. Yeah. So this is later on, but it's not as common that you need to do it, anything. But when you need to know, you have to know it, that you can do it to get the answer for 1 or 2 problems in calculus or something like that. But anyway, this one, just multiply it in. It'll be 2 to the third, like 1 times 3, okay? To the first time, 1 times the 3. Z, negative 9. Is that Z? Oh, yeah. And another Z and a 9. Now, there's another way to do it. In between the parentheses, you can also not raise the third, don't deal with the third power. You can bring that Z down, in between the parentheses first if you want. Imagine that, okay? So there's different order that you could have done. But this one, I multiplied it in, and then I continue with it. So it'll be 8 to the third power 8. Then I'll bring down this here. It'll be Z to the 9th times Z to the 9th. And then I add, right? Same base next to each other. You add the exponent. You understand?
Yeah.
don't forget, there's another z. You're not raising it to another power, so you have to add. So it becomes z to the 18th power, 8 on top. Now, have a look. So this is the answer. But if you were to do it differently, here's the next step. You can bring it down. It's still raised to the third power, but you can work inside between the parentheses. Bring it down first. That z to the third there, but you bring that z to negative 3 down here. Z to negative, become positive 3. Do you see it? You want to look at the original problem? See that z to the third, negative 3? You can bring it down before you, you can do it any order you want. I know that PIMDAS said do the parentheses first. You're way beyond that now, by the way. You can do whatever that you know that you can. Yeah, you know PIMDAS really well by now, but again, you probably don't think about it anymore. But that means you can do this in this order or this order. You could throw in the 3, any order you want, because the property now supersedes every the PIMDAS. Yeah, the properties of exponents supersedes the PIMDAS to some extent. I'm not talking about everything, okay? I'm talking about like the exponent part, I guess. So yeah, you can do, I know you, P first. No, this time because you can multiply the exponent. That's a property that can supersedes it. So you do exponent first, technically, like PIMDAS is like you do EP. Don't worry. Okay, anyway, continue with this. It'll be to the third, Z to the, you can combine the Z. So look, you can combine the z into z to the 6th power and then multiply to the 3. So it becomes, so here, I think you understand that, right? Let me see. So if you continue with this, the denominator becomes z to the 6th power. So therefore, 2 to the 3rd over z to the 18th. And then it'll still be 8. Oh, wait. I made a mistake. 6 times 3 is 18, not 16. So there it is. Same answer. Hey, I hope you follow, Alex, because this different patterns, this different path that you can take depends. You should know all of them because some of you guys will do it one way or another. But I hope you follow. I didn't copy the original, okay? I went to the next step on each one, each method. Because it can get really, tricky and you might miss the sign, whatever, Oh, here it is. Look at this one. They're really pushing it. Here it is. This is what I think. I mentioned something earlier. I don't know you caught on or pay attention closely. I said that if you have a bunch of negatives inside the parenthesis, fraction or not, raised to a negative, multiply it in to fix all the negative to positive. Get it? So that's to clean a lot of it up, not 100%. So this is what you want to do. Multiply it in. Yeah, it looks like you got 4 negatives inside the parenthesis compared to 2 positives. See that? Yeah. So you want to throw it in. So here it is. Have a look. Next step. But be careful though. You still have to deal with the 6 and the 15. So it becomes this. But look at the rest. It's so nice. The rest. A 15, negative 1. Like that. I'm throwing it in. It looks awkward, right? But you can do it. And I think this is the way your teacher may want you to do it. Now, the rest of it, look, it becomes negative 2. Remember, 2 times negative 1, negative 2. Why is it negative 5? Sure, but look at the rest. Right now, they're both negatives, but look at the rest. C, positive 7. You multiply negative. X, 2, the second power. Y, the 6th power, positive. Z, positive 3. Look at how clean. Yeah, you got some negatives there. That's fine. Again, this could be done different. You can flip-flop it and make, flip-flopping it. The sign will still be negative in the parentheses, okay? All of them. But yeah, it's up to you. You flip-flop it and make it a positive and the parentheses will go away. But this way, I think it's cool. Or work in between the parentheses first before you deal with the negative 1. Think about it, okay? You can combine the x's, the y's, the z. Oh yeah, there you go. That way is another common way your classmate will likely do. Or the way I've done here. Some student like cleaning it up, making positive. All right, continue here. Okay, what do you do here? Okay, what do you think happened to 15? What do you think happened to the 6?
So like they're like negatives now.
What do you think happens here? What do you think happens here? Where do I write
Uh,
them?
oh, you could like divide each one by 30.
No, dude. I think you've been distracted. I can tell, dude. It's okay. It's okay, Alex. Um, how do I write this if it's by itself?
Would you write it like -6?
Wait. Let me. What about this here? What about x to -1?
Oh, you would like put it on the bottom
Yes, and it become
and then
+1. What about this one? Yeah, you can write. You can
you
write the one. Yeah, you can write the one there if you want.
you read the that one to the top.
Yep. There you go. And then this one, I'll bring it down next to this one right here. Hey, can we do some mental math here? If I bring this down to the bottom, it'll be another x squared next to x squared. I want to combine them. Could you tell me final answer for the x's in the denominator? I hope you can see it.
Would be 4x, like x to the fourth power
Where? Yes, where?
on the denominator.
Yes. Okay, now what about the y? The two y's combined?
The y would be it'd be y to the 11th power on the denominator.
You okay? Yeah,
Yeah.
good. And then this here, the z.
That would be uh like z to the fourth power on the numerator.
Yes, final answer. Yeah, you got it, dude. Here it is. Now again, you could have done it, like differently. Two more ways, like flip flopping the fraction, combine them in the between the parentheses first, all that, and then put in the -1. Oh wait, sorry, don't. Yeah, this here can be reduced. Oh, forgot. See that?
Yeah.
And I forgot to mention it could have been reduced also before you raise it to -1. You could also reduce it in the original. Okay, don't wait. It's not done, right? So we're gonna reduce 6.
You could,
Yeah, the z, the x, y, z, they're done. But 3 can go into 15 5 times and 6 2 times. So it's be 5, yeah, instead of 15, and then 2 instead of 6. Forgot about that. Almost. All right. But this is, let me see. Okay, let me look at it carefully. -2, -5, +7, 15, -1, x, wait, x +2, yep, y 6, yep, 3, yep. Okay, let me see. Combine.
oh wait, I think I know what happened. I think shouldn't it be like for an x to the fourth power and not to the second power? Because when
Yeah,
we brought the
yeah. You you,
negative
you
two,
you 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 told me that, right? Yeah, you even said it.
yeah,
Yes. Sorry, it's a fourth power. Good. You even said that. Good job. Yeah, that's it. All right. Very good. Very good. Okay. Same idea here. Again, you can do in between. Oh, nope, you can't. Oh, yeah, you can. Okay, let's do one in between the parentheses first. So next step, here we go. Because you can. We haven't done that in between the parentheses, but you can before I deal with the -2. So let's do that first. Have a look. So 3 stay 3, 2 stay 2, but the z, I think you're good now. It's z to the fourth on the bottom, right? Yeah.
yeah,
Okay, and then you can give it up. Now, look, the last one, I threw in a negative and it become like 6 to -1, 15 to -1. It looks awkward, right? You remember that one? Like, the 15 to -1, 6 to -1. It looked kind of awkward. And and you can see that you can bring it down, bring it up, and all that. So you can bypass that. How? I like the next step. If I were to do the same thing as I did before, it would look like this, right? You see it like this, and so on and so on, right? You know how I threw in a negative, right?
Yeah.
If you don't like that, let's continue. Like, okay, I did partially in between the parentheses, right? Now I'm going to go ahead and not throw that in. I'm going to flip flop it because you know the rule now and make it a positive. Do you remember this? Like, remember the rule for flip flopping? Your teacher may
Yeah.
not have taught you, but fine. You now know on one more thing. I don't know. My assumption is that your teacher normally don't until maybe later on. Okay, so I flip flop it. Now I can throw it in so it's clean, so you don't see that weird negative exponent on the number, on the base number based. So I can do 4 now. To the second power is 4. 3 to the second power is 9, and then z multiplied exponent be 8. Look at that. I mixed different method. You see, and get the answer. That's why you should learn all the methods that I showed you. Like so many ways so many paths. There it is. This is done pretty fast, clean. But I mix them all up, dude. I mix inside, I flip flop it, and then I multiply it, and then I throw it in. So yeah, so just think about it, okay? You can do it different ways as long as you know how. All right, this one. Now here it is. I'm not gonna bring it down on the bottom. I put a 1 on top. Why? Why? I'm not gonna like if you were to bring it will look like this. Watch. If I bring it down, it will look. Check it out. If I were to apply that 1 on top and make it a positive on the bottom, it'll look like this. Here it is. See that?
Yeah.
Remember, you have to bring everything down in between the parentheses, including the sign being negative. But the only positive happens on the outside. That's 7. Could you see? Do you understand this? Now, there's nothing wrong with it, but you have to continue. But there's a faster way. Have a look. That's why you want to manage, your work, your path. Which way you want to take? Which way you want to which is the faster way? You multiply them in. You're done, dude. Look, just multiply and I'll show you that it will be the same answer in a second. I'll multiply it. It'll just be 48, positive 48, and it's done. So W48 is the answer. But if you go to continue with this, it'll be 1 over W negative 48. But then you have to bring it back up. See that? Same answer. Yeah, but as you can see, why you have to kind of like look at. Do you want to do that? Positive, negative, making it a bunch of negative, make them positive, and all that. That's where I apply it right here, just for one thing, and it's done. But some student may bring it down like that. You expend more time to do it, but it works. Same answer. You got negative 48 on the bottom with the 1 on top. Bring it back up. But this is done in one shot by multiplying it. I hope you're okay. Yeah. So let's
Yeah.
put in and let's put that in. Oh, what is 6 times 7? I made a mistake.
It's 49.
49. Wait. Is
No,
it
42.
42? Yeah. All right. All right. Here. Oh man, they're really, really, pushing it. Have you practice it, right? So again, let's do it this way. Bring the A. Let's scan A, B, and C. The A's, the B's, and the C's. Here we go. I'll put the bar here just in case. If there's nothing left, it's just going to be nothing denominator, like over 1, But here we go. Look at the A's. I think you can see, bring the 4 up and add it to the 7. So that would be in the numerator. Is that okay? Bring the 4 up.
Yeah.
Or you can do 7 minus negative 4. Same thing. So it's going to be A to the 11th power. I hope you're okay with that. Now B. Now here we go. You don't want to do it this way. You don't want to do b. You don't want to go like 1 minus 2. If you do that, it will be negative 3 on the top, right? So look, we're going to do a mixture of things that you know how to do it. So if you add the b's, bring the b down, make it a positive where you can, right? To make it stay there. So you bring the b down and add it to the b on the bottom, b to the third. Tell me you understand that.
Yeah.
So that's how I would have done it. And look at the c's. I don't want to do 6 minus 5 because that will be negative 11 on top. I want to bring the 6 down and add it to the bottom. This is how I see everything. Yeah, if you wonder. Did you hear that noise? I don't know. My Apple AirPods here sometimes will block it out pretty well. Yeah, there's like a loud car with a speaker, a truck selling secondhand stuff or buy secondhand stuff. It's really loud. It's a music in Thailand. It's everything goes, dude. They make up a song. It's literally it's recorded, but it's about selling or buying secondhand stuff, clothing, whatever. It's pretty cool. The music is pretty catchy too. It's like rock music. It's funny. But anyway, I assume you couldn't hear it, right? So anyway, bring the C down, the 6, and add it to the 5, the 11. Final answer. I hope you see it the way I do it. That's the way I see it. Bring them up where I think it's gonna bring it up, or down where I think they will stay positive quickest. So yeah. All right. Right. Okay. So if you were to bring obviously you want to do that for the final answer. You got to bring that z down to the bottom to be a positive 2 and add it. It'll be c to the third on the bottom. I mean, the 1 will be left. You okay? Yeah.
Yeah.
This is pretty, man, you got like the messiest stuff and then you got the easiest stuff. I don't understand it. It's like, it might be random. It might be, it's computerized, you know? Okay, this one again, you can do a different way. You bring it down, then subtract. But I would add them. 3 minus 5, add them because you got two w's. You know, base, two bases, same base. Add them. It's a negative 2. Then bring it down. So the final answer is 1 over w squared. Add them. It's a negative 2. Bring it down. Make it a positive 2. I hope you're okay with that.
Yeah.
Raise the exponent. Sorry. Okay. Yeah, it looks like fun. Just I would do the first part separate from the second part. You know, the fourth power and the second power separately. So here we go. Now, remember I mentioned that the negative, if you want a shortcut here, you don't want to do negative 1 to the fourth power, which you can. Remember, there's a 1. You don't see it, but it's negative 1. You can do that. Or you treat the first part being positive. Remember that rule? If the whole chunk it's negative, raised to an even power is positive. So you don't have to deal with it. But if you want, you can kind of make a note. Hey, it's negative 1 to the fourth power, which will be a positive 1, positive 1. But you don't need that. So just go ahead and do x to the fourth, z to the 12th for the first part. It's positive. And then, so I work on that's done for the first part. The second part, here we go. Be 3 squared, which is 9. Let me see, you okay with that? It'll be 9. Then x to the fourth because 2 times 2, and then y to the fourth, so forth. Is that okay? This is
Yeah.
my x here. Okay, and then continue. Combine them. Here it is with this, but put the 9 in the front. You know, they like the number to be in the front, the coefficients. Then x to the 8th, same base. Two more. You got two bases of the same. You add exponent 8 z. Oh, I'll put the y first. Doesn't matter. It will accept either one. Y to the fourth, z to the 12th. Final answer. Are you okay with that 9? See that 3 to the
Yeah.
second power? Yeah. Oop. Yeah, you got that. you wonder, can exponent has like an x and y in it? Yeah, you got ax y plus 1. Yeah, but not for this one. Okay, more messy stuff. Just be patient. Yeah. So the cleanest way is multiply them in the top and multiply it in for the bottom separately. Now you probably think something more to it. You can bring the bottom up to the positive, but don't do it because you got more negatives. You want to clean them all up into positive. So watch the bottom. I want to do the bottom first. Look at it because it'll become positive 15, positive 18. Yeah. And the top, it's 4 squared. It would be 16. A, negative 2. B, negative 4. You see, is that okay? So far.
Yeah.
Okay. Then I'll bring down and then combine in one shot. So 16 stays 16. Here we go. We're going to do the final answer. Bring the A down on the bottom into a positive 2 and add it to the 15. Is that okay?
Yeah.
A 17. What about B?
B would be B to the 22nd power.
Yeah. You okay? There it is. On the bottom. Yeah. Okay, that's it. It seems like you've got tons of practice
Yeah.
from working on this. So it's good though. I can see the benefit now. Okay. All right. Like just multiplied it in. The bottom will be positive. I hope you're okay. You can keep the negative to the 6 and then raise the second power, which is negative 6 squared. Negative 6 times negative 6 is 36. Keep it there. Then u to the 6th power, 3 times 2. V to the 8th power. Done. Hope you're okay with that.
Yeah.
36. Looks like. Okay.
Yeah.
So they're not combinable. One is V, one is U, so it's done.
Yeah.
Okay. All right. So yeah, they're really pushing it. Okay. Multiply the number part, the coefficients. There's a 4, a 2, 1, and 5. Yeah, you don't have to think 1. So 4, 2, and 5. So it's 8 times 5. So it's 40. So we're done with the number part. Yeah. And then x. Now go with x first. X to the 4th plus times x to the 8th power. You add. It'll be x 12. Imagine, look at the x's. And then go for the v's. V to the 4th, and then V to the 1st, or V to the 5th power. Do you see that? Quickly, like, I hope you can see it. 4 times 2 is 8. 8 times 5 is 40. And then the x is x to the 4th, x to the 8th. Those are the combinable terms. Same base, add the exponents. 12. Then the v's, 4 and V to the 4th, V to the 1st, V to the 5th. Okay, I guess this is the last one, I think, right?
Yeah, it's awesome.
All right. So, easy. Check this out. The bigger negative you bring it up, it will be combined with the 7. It'll be x squared. Final answer. Do you see it? Bring it up, positive 9, and then you got a negative 7. You add them. Do you see it? It looks like this. If you were to like see in your head, if you bring it up, it will be like this. Like the 9. I chose the 9 to be brought up on top because it will give you a bigger number. You see it?
Yeah.
So therefore, that's it. And then just same base, add the exponent, 9 plus negative 7. So it's 2, x squared. I hope you're okay with that. You can do a different way if you want, but that's it.